Hello and welcome to the second Contemplative Friday since break. This Contemplative Friday is ultimately going to involve a visualization of this reaction between hydrogen and iodine in the gas phase. You don't need to write this down, but I wanted to get some imagery in our heads prior to beginning the contemplation of this reaction. So here we have H2 and I2, and what I'd like to have us think about is, again, when we write H2, we really are thinking about a nucleus for the hydrogen and another nucleus for the hydrogen, and those two are connected by electrons being shared in an electron cloud. Similarly, for iodine, we'd have a much larger nucleus, a lot more protons in iodine, but iodine, I2, would just be held together and by a very large electron cloud there. And when these two molecules get near each other, well, it's reasonable to suspect that if you're an electron in this electron cloud, you might now be attracted to this nucleus because that nucleus is positively charged. And similarly, electrons that are in the I2 cloud might be attracted to the hydrogen proton. And so you'd start seeing electrons making new bonds between a hydrogen nucleus and an iodine nucleus. So this would lead to a reformation of, here's our hydrogen, here's our iodine nucleus, and now we'd have an electron cloud around those two as electrons shift. And these electrons shifting here would produce another molecule there. So then we'd get HI bonded and HI bonded, and there are our two HI molecules. And that is summarized by H2 plus I2 going to two HIs. But what we seldom consider is the back reaction. But when we deal with equilibrium, we're going to have to deal with the back reaction as well. And here it would be the reverse process. We can imagine two HIs running into each other in space. And if that happens, it's possible for the electrons that are in this electron cloud, for these electrons to begin to be attracted to the two hydrogen nuclei, reforming an H2 bond, and for electrons in the electron cloud to be attracted to the I2 nuclei, which would reform the I2. So the forward reaction is these two molecules running into each other with an electron distribution change. And the back reaction is essentially the same reaction, only creating different bonds between H2 and I2. So if you don't catch that, I would urge you to pause this, go back through that before we begin the contemplation part of this exercise. Okay, so now that we're ready to begin the contemplation, I would invite you, if you are interested, just invite you to close your eyes if you would like. Take time to pause, find a comfortable sitting position with your back straight up. And then let your lungs fill with air. Take a long, slow, deep breath in. And a long, slow, deep breath out. And again, take a deep breath in, maybe to the count of 4 or 5. And exhale to the count of 4 or 5. And another long, slow, deep breath in. And exhale to 4 or 5. And one more long, slow, deep breath in to 4 or 5. And exhale to 4 or 5. And now just let your breath become normal. Don't try to control it. Just release it. Let your body do the work for you. Feel the air either going through your nostrils, cool air coming in, warm air going out. Or perhaps you feel it as your belly and lungs expand. Just focus on the breath. If your mind wanders, which it will do, gently invite it back to focusing on the breath, feeling your belly expand, contract, with no effort on your part. It'll do this automatically. And now, like we often do, imagine by picturing a large box. And in that box, we're going to picture some H2 molecules and some I2 molecules. And they're bouncing around. Picture maybe 10 or 20 of each. So we have some concentration, number of molecules in a volume of both the H2 and the I2. Picture their electron clouds. Picture them bouncing off the walls, bouncing off of each other. But now as you imagine an interaction between the H2 and the I2, we talked about that reaction where the electrons are going to be attracted and change their bonding. So imagine that they do that. Picture molecules beginning to do that as the H2 and the I2 collide. You produce two HIs. And the rate at which HI begins to fill the container depends on how much H2 and I2 you have. Add some more H2, add some more I2 in your mind. Because you have more of those reactants, you get more collisions. So picture more collisions. As more collisions occur, the probability that they meet with the right orientation goes up. So at high concentration, right at time zero, you're going to be producing two HIs fairly rapidly. So maybe picture the HIs as a different color to help set them apart. So over time, the H2 concentration in your mind should be going down. It's getting used up by the reaction. I2 concentration should be going down. It's getting used up. So the rate of the forward reaction is slowing down. You get fewer collisions between the H2 and the I2. So in your box now, you should have H2 and I2 and HIs, whatever color you decided to make them. The HI concentration is increasing because you're making it through the forward reaction. So as the forward reaction is slowing down, you now get more collisions between two HI molecules because there's more of them. So picture two I2 molecules, H2, sorry, picture two HI molecules now coming together. The H's rejoin, the I2's rejoin, and the result of that is you get an H2 and an I2. So the HI molecules now begin to back react to reform H2 and I2. And that rate speeds up. So you start reforming H2 and I2. So now in your mind, let's start the whole thing over again. Wipe the box clean, empty it. You're going to put in H2 and I2 molecules, no HI. Right now you have the highest concentration of H2, highest concentration of I2. The rate law says rate of reaction is equal to K times those two concentrations. So at high concentration, high rate of forward reaction. So let the H2 and the I2 react very rapidly, lots of collisions to form two red HIs. And let them appear, bang, bang, and then another one appears, bang, bang, and another one appears, bang, bang. But they're starting to appear more slowly, bang, 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 because the H2 and the I2 concentrations are going down. But as more HI builds up, HI collides with another HI to remake H2 and I2. And its rate speeds up as the HI concentration increases. Its rate is equal to K times the HI concentration squared. And at a certain point, the rate at which you are making the HI is equal to the rate at which the HI is going away again. So in your mind, you eventually reach a state of equilibrium where you have some H2, some I2, and some HI. And just as fast as H2 and I2 are making HI, HIs are colliding and remaking the H2 and I2. So there's no net change. The concentrations of the H2 and the I2 and the HI no longer change like they did at the beginning of the reaction. You have reached an equilibrium state where the rate of the forward reaction is equal to the rate of the reverse reaction. The concentrations aren't equal to one another. You might have a lot more H2 in your mind and a lot more I2 than you do HI, and that's good. Those concentrations aren't going to be the same as the HI concentration. But the rate at which you're forming HI and the rate at which HI is back reacting to reform the reactants is equal at this point. So there's no net change, even though there's a lot of change going on. H2s continue to react with I2s to form HIs, but just as fast as those HIs are forming, they're reforming the H2 and the I2. That's equilibrium. So I encourage you to give that some thought, continue to think about that, look for systems that are at equilibrium in our daily existence. There's really not many. The universe is constantly changing. In fact, one of the Buddhist principles is that everything is always changing. Maybe slowly, maybe quickly, but the universe, the one constant is change. But microscopically for chemical systems, we can say that some systems come to this equilibrium. And it's a very important concept. So we need to be able to think about it and picture our forward rate being equal to the reverse rate. At this point, I would encourage you to return your attention to your breath. Just feel it coming in and out of your body, wherever that manifests itself. Sensation in your nose as you breathe in through your nose, or in your expanding lungs and belly. And if you find yourself distracted by thoughts that pop into your head or noises around you, return your attention to that breath. The other things are just going on around you. Focus on the breath. Gently check in on your posture. Are you still sitting up? Giving yourself this time to be calm, be at peace. And I would invite you to take a long, slow, deep breath in through your nose. Long, slow exhale. And another long, slow, deep breath in. And a long, slow exhale. And on the next inhale, begin to wiggle your fingers and your toes. And you're welcome to remain with your eyes closed for a little more time, or gradually open your eyes, come back to the day. I hope you have a good weekend. I hope you and your family are staying safe, and I hope you enjoy this day. Thanks for listening to this.